Jones team, so we'll figure it out. So Polyminis, you've heard the word. It's a game about evolution. So let's get into the detail. What, why, how. So as I mentioned, it's a sci-fi game. It's a zen game. It's a sandbox game. It's not about winning. It's not about losing. It's not so much about the points. Why would we want to make a game like this? I think, I personally believe that nature is awesome, and the processes that have shaped nature are pretty darn awesome as well. Evolution, but as well as pretty much any other stochastic system that exists in nature, like erosion or how rivers take their shape, or and lately, how we're going to achieve that is our main differentiating factor is that we're actually using evolutionary computing, genetic algorithms, neural networks to work all this stuff, and we're not just adding a plain code on top of an arcade game, right? So how does it work, like, really? At its heart, Polyminis was a project that was born like a year and a half ago, and it's just a framework for evolving creatures. So it's pretty much you just tell it, you just give it like a function that says, move a lot, and the system will try to find ways that the creatures will move and satisfy your desires. Obviously, it has like a bunch of layers there, but at its core, it's just that. It just tries to match maximize some number that you're telling it is doing okay or not. The game we're trying to build is just a way of abstracting all that framework and all that science into a way that everyone can just play around with it instead of having to know evolutionary computing and all of that stuff. And it's just like imagine it as some sort of science kit that interacts with evolutionary computing instead of chemistry. So what is our core loop? So basically you explore the universe to find places that are interesting, and by that we mean planets. Those planets have certain characteristics that are procedurally generated and that present a challenge of diverse variation for your creatures. You evaluate the planet and you say, well, I think I'm going to design a creature to beat this challenge, or to, beating is a complex word, but it can mean even like symbiosis, right? You don't have to eliminate everyone on the planet to win. You can have a creature that is like really plays along with other creatures. And lastly, then you see your creatures play along or not with the other creatures, and then the idea is that by then you have that moment of, I wonder what will happen, and then you go back to either exploring or redesigning the creature, and that will happen. So the art vision, they started like that, and then they evolved. These are art concepts, first pass, a little bit of playing with how animation looks like. This is not spore level creatures, like they don't have joints that are like full IK. Sorry. These are 2D creatures that move in a 2D world that we're just trying to abstract to like show some interesting patterns, right? And pretty much that's where we arrived. And this is our current like target for like 3D, simply 3D right now. So technical design. I like to talk about servers because I'm a server engineer, so that's the stuff that I like doing. So unlike most of the projects here, we actually started from our back end into the front end and not the other way around. So if you try to follow these as colors, green means we're actually on track or slightly ahead. Yellow means we're pretty much hitting it, and then orange means we aren't as good as we should. We had a couple of big things happen in like the project. One, we switched engines halfway through. That hit us kind of hard. And then the second one of our main 3D artists dropped the class from LCAT, and our secondary 3D artist have her grandma pass away. So it's been a hard road for us. So on the server side, we have had not a lot of eventualities, and also most of our expertise was there from the beginning. So we could manage that. The front end and the parts are not as good as we would like. So real quick. Segue into production, they're good. We barely hit our MVP as described in the game design document, which was the backend simulation is done, and we have the 3 activities in engine basic integration. And that was like, there's a comment on the Google document for the GDD that says if we only hit this, something really bad happened. Apparently something really bad. But on the flip flip side, our infrastructure is really good. We can iterate pretty fast. We can pretty much save anything into a database by sending a request into a web server. What other cool trick we have? Yeah, this guy. I love this guy. Carlos, he is in charge of evolving features every day, just so we have like fresh tests. The bad is, as pretty much every team has explained, complex systems in socialization. Like, it's really hard to work with people that are remote. It's really hard to work with people that are not experts in the thing you're trying to do. You know, like you get an artist who's really good in Unreal, but you're in Unity, and then he like ensues. And the ugly Lumberjack was really bad for us. The switch from Lumberjack to Unity, and lastly, like churn of volunteers, as people have mentioned, like people coming and going, or people coming and not really like delivering as they say they would. Hurts a lot, especially since we're a small team. If one person fails, that's like a 20% failure in our case, so it hurts us pretty. But yeah, with all that, I can take some questions and then segue into the demo. And webpage, polyminis.com.
So, like, how complex is this algorithm that you're running the simulation on? Like, does it have to be server-based, or is that just so that multiple people have access to that same simulation at the same time?
So the idea of having it server-based is so. What is it outside?
You good?
There you go. Okay, so you can run it in your laptop, and you can run it in your laptop with Unity. That wouldn't kill it. The idea is we can keep growing it until it cannot run in your laptop if you want. If we keep it over there, or so something I've been trying to look a lot into is how games and some techniques that have not been explored by games can play pretty nicely, and this is one of those examples. So AI in games has not had like a really big breakthrough since Halo. So I mean, I'm not saying this is it, right? But I'm saying that we should try it at least. And I'm thinking one of the big things that can benefit is cloud-based AI. Now that you don't have to run your AI and your graphics in the same box, maybe we can do some cool stuff with it. So that's part of the point I'm pushing. So there's no like heavy reason for it, but it kind of makes my point. So that's part of it. And originally the architecture was trying to like leverage Lumberjack and GameLift, so that kind of fell into place. Right? More questions?
What's Kronos?
Kronos is just Kronos is a god of time in Greek mythology. Here is just like a Python script that lives in AWS and every now and then just pings the simulation server and grabs the results into the database. That's wrong. Or the database is called the Almanac because we like names. And with all that said, the art is pretty rough in the edges, so bear with us. Alright, so I mean, we've seen some of this. Space is awesome. The idea is we actually unloaded a lot of this screen because we want to actually repaint space and make it like super inspiring. As I said, nature is big in our motivations. And then star map now. We can generate as many planets as we want in any arbitrary positions. Like space is infinite to a point. I mean, there's probably like numbers will run out in the computer kind of thing, but there's nothing preventing us from just creating more planets and then placing them. We managed to implement warp. One of the cool things of not having artists is that you get really creative with using math for colors. So these, each planet has like a range of temperatures. So the artist came up with like 3 colors for cold, hot, and temperate. And then we just hooked that up with pretty much all of our systems, add a little bit of noise, and then a shader. And then all of our planets now shade based on their temperature. So if you're running out of artists, procedural art is pretty good if you're over-indexing in engineering. That is a lesson. So now you find a planet. So basically the idea is you're going around in space. Usually you wouldn't have a grid of planets in front of you. You would have to find them. And once you're close to a planet, you get to orbit it, and once you orbit the planet, you can see which creatures live in that planet, and this planet has a cool dudes. And you go into the editor for it, and this has become pretty much like our main metaphor for gameplay, which is the 4 instincts for the creatures. Each one of them abstracts a bunch of heuristics in the simulation. So, for example, the nomadic one abstracts the heuristic for moving, the heuristic for like being far from when you started. The herding one pretty much keeps track of you being around the ones that are like you. The predatory one tries to like make you attack other creatures, and that's the idea. They're supposed to be a super cool DNA rendering over here, but will happen later. And once you have your creature ready, you save it, and then you go back to the planet, and then you get to like, shoot it into it and observe it. And then this half and half of like balls and stuff. I think these are just trying to go to hot places, so they're going to gravitate towards the red. There are some dum-dums that are going to just get stuck. This is like generation 20 something, so they're not super smart. But I mean, this was getting done like 4 in the morning, so. But in the original simulations around generation 100, they're pretty much able to do whatever they want. So and after the rewrite of the simulation, we're hitting like 1 full generation, which is like 400 simulation steps times 3 per species in like 1.5 seconds. So that was super surprising for us as well. We were expecting the first time it was around in the minute mark, which was still pretty decent. Now in the second mark we can do some curious stuff. So that's one of the silver linings of having more server engineers than you need. That you get some cool optimizations here and there. And again, this shader is using the same, well, this is the same shader using the same idea, but the colors are much more diffuse because the simulation uses like temperature diffusion for the water, and then if the water, if a creature is in the water that is colder water, it will die and stuff like that. And yeah, for next semester there's a lot of like art, hitting it hard in the procedural side, I guess, because we've seen that engineering has been more manageable for us, similar to you guys, and yeah, keep building stuff. Maybe writing a paper or something.
Awesome.
Okay. Questions?
For the procedural map, are you doing like a grayscale of cold to hot and then running that through like a gradient map? Or?
So the opposite actually, but yes. So what we do is the server sends down the like diffuse temperature. So pretty much like these, they're like generators of temperature, which is like water that is flowing from there, and it just like starts dispersing. And then like this is a pretty simple dispersion, like quadratic distance kind of thing. And then pretty much like this is just the temperature, and then goes into the shader, and then we just need like triple interpolate because it can colors, and that's it. But what you were saying, but the other way around, instead of grabbing a grayscale and going to color, we just get a number and we.
So Ricardo, we know that the core loop for the player is explore, create, observe, but can you talk a little bit more about what the core loop for the actual Polyminis are? When they are, do they have a typical loop that creatures that we know them have, where they're born, they try to survive, they reproduce?
Sure. So it's using like the basic genetic algorithm metaphor, which is you pretty much have a generation where you clean slate and create a new generation. So that means either you grab, that usually means you grab stuff from the previous generation, like the good stuff from the previous generation, and fill up your new one with like mixing and matching. Like you pretty much reproduce them.
How do you quantify good stuff versus bad stuff?
And that is where the instincts come into play. So right now we just have like a bunch of heuristics, which is just a bunch of math functions. One of them is just move. Like we want them to move. We believe that moving is good for life, so we ask them to move randomly. That is good. We also ask them to move far from where they started. So that's a different heuristic. And then we add those on. And then there's another one about staying alive is a pretty big one. So don't get eaten, don't stay in water that is too hot or too cold. Actually, something weird we saw this week is the system that places them. If it cannot place one because it got too big because they can evolve their chicks as they want, it discards it. And what started happening is it's actually pretty much seen here to a point. One of the species starts growing too big and the other one starts growing small. So the big ones we try to make the other guys discard it, and that just kind of happens because it's good for them. They don't even know why. So we have a bunch of heuristics that kind of add up into like smart features, but it's just like a bunch of very simple math, and every now and then we come up with a new one and we just add it. But it's super easy to add new ones, so that's the cool stuff. As I said, our infrastructure is very flexible right now, so we can do a lot of stuff. Maybe that was part of the curse, which we were like a little bit too distracted instead of trying to bring it down to a few. But at the same time, we can do a lot, so, which is fun.
Nice. And I have a follow-up question, actually. Do you have a naturalist, somebody who actually does taxonomy and this sort of thing for a living that you have as an advisor?
Yes, so I have 2 biologists and 1 astronomer. And originally, the guy that was going to be the lead engineer, Jonathan Plonner, he actually did a minor in biology. So we talked a lot about that, and then he had to leave the team. But yeah, we're keeping a lot of that stuff in mind, and also normal genetics, like CRISPR and all that. That's super exciting.